Good afternoon and welcome to today's webinar on Complete Cybersecurity, 3 ways to go beyond compliance when protecting manufacturing operations from malicious foreign threats. My name is Chris Hamilton. I'm the Director of Grantek's Industrial IT, OT, and Cybersecurity Group. And joining me today is Jason Campbell, Channel Account Manager on the IAS Solutions for Panduit. So our agenda today is going to be a quick introduction over myself and Jason, and then kind of a brief overview of why are we discussing this topic right now. When we get in a little bit deeper into the technical details, we'll talk some of the top cybersecurity weaknesses of ICS systems, boundary protection, least functionality identification, authentication, physical access control. Go through a little bit of a summary and some statistics, and then a quick overview of what you can do in order to protect yourselves from this developing landscape. So also a reminder throughout the presentation today, if you have any questions, go ahead and shoot an email to my email at the top bar there. It's chris.hamilton@grantek.com. And if you're watching the recorded version of this and have any questions or comments, feel free to reach out to that same address. So a brief introduction on myself. I'm 12 plus years in controls and automation, about 15 years in IT systems and cybersecurity, primarily web and database is my original background. I co-chair MESA's cybersecurity working group with Eric Hausman. MESA is a group that strives to take standards and industry best practices and to develop white papers and other ways of kind of taking that information in at a technical and a technician level. So primarily my day-to-day is a consulting focus, working with our partners, working internally to Grantek and working with our clients to really bring the understanding of the corporate IT world, the enterprise IT, and the OT gap. So bridging that, having people talking on both sides, leveraging solutions and understanding on both sides around what can be done in order to really be what I call a good cyber citizen in this world. So doing the correct thing, doing the right thing, protecting your own IP, protecting your systems, and protecting others.
My name is Jason Campbell. I'm Channel Account Manager for Panduit. Been with Panduit for over 12 years, specializing in industrial networks and IoT solutions. Currently, I support Northeast and Canada at the end user level, and also working with partners like Grantek to deliver physical layer solutions to our customers.
So why now? If you look at the 2-year rolling average of ICS-specific vulnerability disclosures, so starting around 2000, 2001, very, very little. Starting 2008, 2009, you started to see a significant increase. And up to 2015, which is the end of this chart, very, very, very significant increase in ICS-specific vulnerabilities. So that's not tracking the industry as a whole. That's tracking, the manufacturing world, the critical industries that we care about. And as I've given a couple of different seminars and webinars on cybersecurity, and what I kind of see everyone take away from that is a lot of questions and a lot of uncertainty around what they can do to help. And what I was watching or listening to NPR's Hidden Brain the other day, it kind of it resonated with me a little bit, and I wanted to kind of go through what I see in cybersecurity a lot. And the base philosophy of this is a person should never avoid information, because information can hurt a decision. But what frequently we see in cybersecurity is it's scary. It's something we don't want to find out how badly we're doing at. And because of that, what they call the ostrich effect. We tend to stick our head in the ground and pretend that everything is hunky-dory. So this specific study, they said, okay, will people pay money to find out good information? So they gave people envelopes, and then they said you have to wait 20 minutes to determine if you won $10 or $100. And they said, okay, if you want to pay a small sum, you can open that envelope early. So the interesting aspect here is that people had no ability to change the outcome of their situation. They were either going to win $10 or $100, and whether they paid money or not, it wasn't going to change. But what they found is 83.4% of people were willing to pay money in order to get that information sooner. So they wanted the reward because they knew it was positive. And the inverse, and this is a bit of a spoiler for the episode, but you should still definitely go check it out. It was quite interesting, is that they took and they found, a uncomfortable situation. So they found, they took a group of college students and they offered them free genital herpes testing. And they got them to agree to take this testing, and they got them to agree to draw the blood. And then at the end of that, they said, okay, now you can pay $10 to dump that tube out into the drain and never know. And you don't have to go through with the test. They found as many as 20% of the students were willing to pay money in order to avoid having an answer. Positive, negative, didn't matter. They were willing to avoid having that test done at the end of it. So what they're proving basically is that we have a tendency to desire and want positive information, and we have a desire to avoid negative information. So keep that in mind when we're talking through this, and when we're talking through what can be done to help. One of the other reasons is why we're talking about this now is because cybersecurity is expensive. The missteps that companies have had in the last year are extreme. If you look at this specific report from SANS talking about WannaCry and NotPetya, which were two very large incidents of 2017, you'll see that FedEx, TNT, material losses of around 300 million. Merck, Mondelez, lots of large, well-known companies that were down between days to weeks to months for some systems in order to bring them back online. And each one of these companies had to report that to the SEC because the amount of losses were so large. So this is one of the first times we are really seeing a large financial hit to companies' bottom line that requires them to be reported, because the feeling in the cybersecurity industry is that cyber events are kind of like they're embarrassing. You don't want to necessarily tell all of your competitors and friends, hey, I got hacked. So it goes very underreported. When the losses are this large, they have to be reported to the SEC and the public, and we're starting to really see the magnitude that these things can cause, the damage. So another prime investigation that came out in March was the Department of Homeland Security released a report talking about the Russian government activity and how they have been targeting the critical infrastructure sectors within the U.S. over the past couple of years. So the areas that they identified targeted by the Russian government were energy, nuclear, commercial facilities, water, aviation, and critical manufacturing. And they actually were able to do a case study, and the link is in the bottom there. You can go through the very technical details. It'll show you how they navigated from company A to company B, used credentials from company B to go to company C, and use spear phishing, watering holes, various other techniques. And over the course of multiple years, we're able to get access to control systems. So this screen that I'm showing right here was actually captured and replayed as an actual live session that was the threat actor able to access. So what happened was nothing. Nothing happened. The reason nothing happened, we don't have an answer for that. The magnitude of this report is that they were at this screen. They could have taken this system offline. They could have caused damage with this system. They had full access, unencumbered, and this time they decided not to act. But they have information, they have gotten into critical industry, and they have been able to pull out a lot of information about how the American power grid works and about how other critical industry sectors in America work. So that's very, very, it's critical to be paying attention to these things right now. And another, couple of reasons why this is so important is because companies are relying more heavily on third-party vendors. They're relying heavily on partner systems, ecosystems, which is great because you can contract out and get a higher skill set than maybe you could maintain in-house. But at the same time, we're also more connected than we've ever been before, all of our systems. And with that, you would think you would need a higher focus on security. But funding and the need to move quickly has really pushed the industry, especially manufacturing, to provide VPN and remote access in an unmanaged fashion. Throw a an E1 or throw another device out there, and those devices can be used and managed correctly, but unfortunately they also can be used simply for their ease of use and not monitored, not maintained, and then they can be a security risk. The increase of phishing, password cracking is massive. You've probably seen increase in spam emails, and with that, on the individual user side, password reuse is a huge problem. If you use the same password to log into your enterprise as you use for your Gmail account, as you use for your band's website, then if one of those is compromised, the first thing that these guys do is they take those username and password combinations and try them everywhere else. And that's how they spread a lot of times. As an overarching thing, legacy networks, especially in control systems. We're looking at networks that were created in the 90s, mid-90s, early 2000s, and it was easy enough to take some PLCs and some drives and plug them together because Ethernet was plug and play for the most part. And now those networks have grown and they have not scaled. So we are asking those networks to provide us, down to the second real-time information to put on dashboards and charts and archive and historians and print out here and get accessible on your phone and over there. But at the base of it, these networks were not originally designed to do that. So the question is, where is your company within the maturity level of that physical and logical design? And are you asking too much of your current network in order to do what you want it to do? And with that, just a general lack of skills and funding, as I said earlier. So the fiscal year 2016 most prevalent weaknesses report put out by the Department of Homeland Security listed these areas as the top areas, and we're going to go through the first four here. So boundary protection is huge, and especially in critical control systems. You'll find a lot of times that either intentionally or unintentionally, the PLCs and controls assets are accessible from the enterprise side. Maybe someone sits at his desk and wanted to get online with the PLC, so he plugged a cable over there and connected it up. Or maybe classically, the company had managed IP spaces and allocated some for controls and allocated some for enterprise, and there's no segregation between them, and it just kind of is running in that fashion. There's a million reasons as to why we are where we are today, and the key is to start identifying that these are problems, even though they've been that way for a long time, and now they are being exploited more frequently than they were previously, so we need to do something about them. Number two is a very simple concept: least functionality. So least functionality in the controls world is very difficult because it decreases your access per se. It slows things down, and the frequent answer to things is to, okay, just give them the administrative credentials, give them admin access, don't lock them out. Whoever they're doing, they're trying to bring production back online, let them go. The problem with that is you don't have levels of security, and this plays in with number three, identification and authentication. So the two of those together really make it difficult to provide granular control to your vendors, to your individuals, to whoever is accessing these systems, as well as it makes it very difficult to trace and figure out what happened. If everybody logs in as admin, then you're not going to know if contractor A, contractor B, or someone in your own organization was responsible for whatever happened. Whether it was malicious or not malicious, you won't be able to follow that, and therefore you won't be able to learn and improve what's going on. And number four, physical access control. So this is, hugely important in industries like power generation and site, where there's remote sites, oil, etc. And the physical access is the, in many ways, the last line of defense, because if you get physical access to a system, you can almost certainly get in and modify whatever you would like to it. So those are the areas we're going to go through today. There's some more, and if you want to look at the full report, there's quite a lot of information looking over the past years as well. It's but looking at 2014 to 2016, which is where I want to start, boundary protection. is, on the logical side, the most important. So when we start talking about boundary protection, we can immediately jump into remote access. So whether the corporate network is separated from the ICS or whether the ICS is separated from the internet, if you ask yourself that today, some people on the call, you may know. Some people on the call may know that they think they have policies, and others, you might not really know what that landscape looks like at all. And wherever you are in that process is fine. The idea is don't be an ostrich and find out, right? Have someone take a look at that and say, okay, we are here and this is why, or we are here and this is why. The difficulty of not knowing is that attackers can gain access to users' accounts, and then they can use that to move laterally across their networks if they're not properly segregated. So this goes with password reuse, this goes with spear phishing, this goes with a bunch of other concepts that we'll talk about, that we have talked about. And once the attackers are able to get into those systems, they're able to move around much more freely than they should if you don't have proper boundaries defined. Similar to boundaries, isolation of devices. So what we find a lot of times in the controls world is we have an enterprise system that is fairly well segregated, well managed, right? You can't plug in and do things that you shouldn't be able to do, and sometimes that's frustrating. You can't print to a printer, or you can't send an email because it's been blocked for some reason, security-wise. And on the control side of things, we, for the most part, have lived in a lot of ways, been able to kind of push that aside and say, well, we don't need that security or segregation because we think it's complicated and we need to make sure that we're continuing to run, our processes are continuing to function. So a lot of clients either have a single VLAN on their control system, or they have multiple VLANs all connected together. And you'll even see a lot of times that the enterprise groups like to treat the control system kind of like a black box. Here is one VLAN, here's an IP space, and here's a black box. Or maybe it's by machine or by building, but however you're parsing that up, it's a black box that doesn't, that different groups don't want to pay attention to. And that's incredibly dangerous, because when you don't have controls and monitoring on that black box, then you don't really have any ability to understand what's happening in there. One of the big and very simple things to fix, default native VLANs. So each vendor has a specific best practice for how to configure those devices. And what ICS Cert found out is that a lot of implementations did not even do that. Did not even change the defaults. So another primary boundary that they determined was an issue was insufficient hardening of cloud services and SLAs for critical ICS functions. So some of you may be at the point where you are leveraging cloud services, and some of you might not be. And some may think that everything is within the four walls, but you're leveraging a service contract with an integrator or a partner or someone that stores information on their own systems. So the definition of cloud is much wider than a lot of people think. So it's not okay, I'm hosting my servers in AWS or with Microsoft Azure. But if you are leveraging services, database techniques, or alerting, a lot of times that data is stored other places, and that's perfectly fine. But you need to understand how that data is stored, where it's stored, what kind of access you have, what kind of access other people have, and do your due diligence to understand that sharing that information could potentially be an attack vector or a loss of IP for your organization. So moving on to numbers 2 and 3, least functionality, ident and authentication. I wanted to take a look at some other reports here and looking at specifically privilege misuse. So cyber espionage, the incidents in this pattern include unauthorized network or system access. So when you think of cyber espionage and hacking, a lot of us think of some nerdy teenager sitting in his computer and writing a script and getting into some web server somewhere and doing something, which is the classic Hollywood thought of what a hacker is. The reality in today's world is that these individuals are not little script kiddies, as we used to call them, but they are state-affiliated actors. They're nation-state actors that probably go to work in a suit and tie, and they are very well funded, and they're on teams. They are on cyber offensive teams, and they are looking around to see what they can see, right? We're not per se in a cyber war, but that is the future, right? That is what is being explored and explored on all sides. So the U.S. is very much involved in that. You look at Stuxnet from a while back. It's pretty much common knowledge that that was a collaboration amongst a couple of different government groups in order to create that. You look at what the reports we're seeing about Russia and China and North Korea right now. So all of these nation-funded groups are seeking out into the internet and poking around what they can. So privilege misuse is a huge problem. Specifically, dialing into manufacturing. So the estimate is that a cyber criminal can steal a year's worth of your planning, research, and development and other secret information, and then use that to bring your idea to market first and more cheaply. So if you have specific IP or a specific process, then what they found is that it's very easy for this type of process to steal that, reproduce it, make it somewhere else, and you've lost your competitive advantage. So they're saying the cyber espionage is prominent in manufacturing and accounting for 31% of all breaches. In the same vein, access control, specifically around virtual machines. So previously, before virtual machines were very popular, you'd have a physical server and you'd have to buy that server, go through procurement, install it, configure it. There were a lot of controls that went into setting that system up. And everybody said that it was great when we went to virtual machines. You could spin things up in minutes, you could spin up new services, you could spin up web apps, you could install new software, and all of that is true. However, the difficulty comes in when all those systems are accessible at the same level. Again, admin, or are accessible by people that should not have access to them. Whether it's on the enterprise side or whether that's on the ICS side, it doesn't matter. It's inadequate segregation of those systems. And that they found is a very, very single point of failure that someone could use to gain access to all of those systems. If we kind of look at the exploits of the past year, the side channel exploits for Intel processors, then that's similar to this, where they're finding that speculative processing meltdown inspector can potentially allow someone in one virtual machine to gain access to the memory of another virtual machine and damage and or change and or modify data as it goes through. And another one which we don't necessarily think about a lot in the controls world is bring your own device. So if a company allows its integrators and its vendors and potentially its employees to come in and use their devices on the network, then you effectively have a BYOD policy. And as a client, that is a risk that you're assuming and you're accepting, and it really depends on your trust in the partners. I would say trust Grantek, we're great, awesome, etc. But at the same time, we do a lot of things to make sure that our antivirus is up to date, that our systems are patched, that we're paying attention to this. And any client does not necessarily have the control over that. So if you are allowing integrators to come in and plug directly into your networks, then you just need to be aware of the potentials for that. If you have a defense in depth plan in place and you have OEM integrator one come in and plug into their own machine and that's all they can access, then that might be a perfectly acceptable policy. If you have the same scenario but they have access then to your entire enterprise, then there's a lot higher risk there that you are either knowing or unknowingly assuming by doing that. So looking at this in the ICS vein, it is very important to understand what the implications of allowing devices from the outside are. And so moving on to the fourth one, physical access control, I'll pass it off to Jason.
Thanks, Chris. So this section, we're going to discuss the physical layer, layer one, and bring you some basic concepts on how to secure the physical layer of your network. When discussing cybersecurity, the physical layer is often an overlooked element of it. However, it does play a significant part in your company's overall network security procedures. Not only do you have the need to protect against malicious hackers or the occasional disgruntled employee, but you also have to protect against the well-intended person who unwittingly installs malware or creates other access points to the network. Following standards and best practices along with designing a robust physical network can reduce the chance of a breach, or at the very least, speed recovery, time to recovery from an event. On this slide, you see at the bottom a statistic that internal threats account for 40 to 60% of attacks. So physical layer hardening can help reduce the chance of that occurring. And one of the most pervasive issues that we see is something we call network sprawl, which an example of that photo there shows uncontrolled growth of the network. Every day we're adding 160,000 new industrial nodes to our network. And there's very little forethought and planning and design given to the growth of our network. And so our networks quickly become out of control, unwieldy, and difficult to protect. So there are standards out there. We're not really going to get into them too deeply, but I listed TIA and CPWE. TIA is a standards body, Telecommunication Industry Association, that has a lot of good standards to follow. The CPWE is a reference architecture created by Rockwell Cisco, and just a year or two ago, Panduit added components of the physical layer to that document as well. And there are a lot of other good best practices and standards out there in the industry to follow. So I too have an access control slide. It's very much a top of mind topic nowadays. It's one where we see increased investment by our customers. The convenience of easy access to equipment on the plant floor is really now being outweighed by the importance of securing these high valued assets of the network and other devices. Most control panels on the plant floor, you can just open them with a quarter turn latch or a screwdriver. That doesn't really provide much physical layer security. Forward-thinking companies today are starting to move critical network infrastructure assets out of cramped OEM panels and putting them into their own enclosures. Sometimes you'll hear those called industrial zone enclosures. Basically, it's a NEMA box on the plant floor to house the industrial switches and other network components. Taking the concept of a zone enclosure a little step further, we can apply IoT type devices like smart locks to enhance security as well. So you can see in the photo there showing the Panduit NEMA IDF, 12RU IDF, and the traditional IDF that we originally offered had two traditional latches, one at the bottom and one at the top. And now we're starting to see a lot of demand for badge reader access. So you have an RFID reader and also an override key lock on the top latch. So this is part of an overall defense in-depth approach. And it's about creating extra layers of security on the plant floor. Another aspect to monitoring and protecting the network is network visualization tools. So one of the biggest common problems OT managers face is understanding what devices are actually out on their network and tracking those assets over time. Manual documentation of any network is very expensive, it's cumbersome, it's subject to errors, and it's very seldom maintained over time. So tools like Panduit's IntraView software, which is in the screenshot to the right, provides 24/7, 365 monitoring of all the devices from the core out to the edge of the network. It tracks all moves, adds, and changes. They're all captured. The software is pinging devices multiple times a minute. And whether it's interview or software like this type of software really helps to let you understand what you have on your network and have a better grasp of who's having access to it and where your devices are located. So if a contractor comes in and plugs in a laptop, you'll be alerted to that change, and you'll know whether that was something that you allowed or something that needs to be flagged and investigated further. Continuing along the defense in depth approach, you can take security all the way down to the port level. There's low cost, easy to deploy lock-ins and block-out devices for data ports. They're simple, effective tools that help to prevent network access. There's a basic rule of thumb that there should be no open ports on the network. You should block out any open ports on devices, patch panels, and telco outlets. Similarly, we have devices that can lock in cables so that they're difficult to delatch or disconnect a cable from its port. So in combination with the lock-ins and blockouts, you can gain security all the way down to the port level. On this slide, on the left is a USB lockout. As we all know, USB thumb drives pose a high risk to any network because they're pervasive, they're easy to use, and they can run executable files. So USB blockouts are very popular. We have them in A and B, which is the middle section there. And then on the static switch, you can see both lock-ins and blockouts. So at the 3 RJ45 cables at the top right, the red section there, those are lock-ins, making it, you need a special key to disconnect those cables. And in all the open ports, there are color-coded blockouts as well for both the fiber and the copper. Continuing along the same thing of protecting the ports, you can move into higher level security using keyed connections. So it's just another option in your arsenal of security devices. Basically, whether it's copper or fiber, the keyways for the RJ45 jacks and plugs, and also the LC duplex connectors and couplers, are unique to the color. So the color combination, black goes into black, red into red, and you cannot mix or match those. This is very popular with military and government agencies, and it's a great security enhancement to your network. One word of caution, if you do move down this route, spare parts are definitely needed because you can't just run out to Best Buy and get any old cable to fit into these patch panels. Another really simple tool that is often overlooked is just leveraging the multitude of color cables that are out there. Establishing a color code scheme for your network cables isn't necessarily a top cybersecurity measure. However, in the event of a breach, it can help minimize network downtime as you attempt to recover, whether you need to manually disconnect equipment or trace cables, color coding network cables. You can have one color for your enterprise network, one for your safety, one for your motion, one for your PLC network. It's really up to the company and how complex of a color coding scheme you want to get into, but it's an easy way to add another level of security in a defense in depth approach. And continuing on at the port level, one of the things that people do least out there, but it's one of the least expensive things you could do, is just proper labeling of cables. I can't tell you how many times I walk onto a plant floor and things are not labeled or they're not labeled properly. Every port, cable, patch panel, cabinet, and device should have unique identifiers to it. TIA 606 provides guidance into proper labeling techniques. And in the photo, you can actually see, if you can read that legend there, that label tells me where it's connected at the near end and also where it's connected at the far end. So, and that follows TIA 606 standards. So the AB04 indicates my location or cabinet that I'm in. The 24 indicates the patch panel position within that cabinet, so that could be RU24 in a data style cabinet. And the 12 indicates the port location within that patch panel. And without even tracing out the cable, I can tell you that the other end is also located in the same cabinet in RU position 36 and port 24, just by reading that label. So there's probably a switch in that location that it's connected to. You can also see the lock-ins being used in this photo as well. So rule of thumb is that each cable label should accurately tell you where both ends of the cable are connected. Last slide I have today is around just hardening your strategic cables. Rigid conduits are often deployed for environmental reasons, but they can also be used for security reasons as well. Protecting your critical permanent links by installing in conduits increases their durability and protects from intentional or unintentional physical attacks. Because of the cost to install conduits and difficulty for moves, adds, and changes once installed, conduits should be carefully considered and probably only used on permanent link cables unless environmental concerns dictate their necessity. If conduits don't meet your requirements, but you still need some security on the cables, some hardening of the cables, you can buy armored cables. So armored copper and very typically armored fiber is used in open trays when some enhanced security is needed.
Thanks, Jason. So we did have one question come in here asking if we would be distributing the slides as a PDF, and yes, we will be able to send out to everyone those slides after this presentation today. And if you have any other questions, feel free to email them in as we go through kind of the summary. So to summarize, step one is don't be an ostrich. Don't ignore the problem because you're not certain of what you might find. The first thing to do is to take small step forward to understand where you are today. So the kind of the phrase of don't let the great be the enemy of good, or don't strive for perfection and not do anything at all. That's kind of the biggest takeaway that I would like everyone to have from here, is that it's an ever-evolving landscape, and the companies and their partners need to move together in order to increase the maturity at all levels, and that's the first and best thing that can be done there. One thing I wanted to go over a little bit is defense in depth. I know Jason and I both kind of mentioned defense in depth in a little bit. So what DID is, defense in depth, is a core concept, meaning that you never rely on one specific measure. So you don't take one firewall and make that the entire concept of your security, or you don't take really big concrete blocks and build it all around your facility and use that as your only defense mechanism. So defense in depth means multiple layers of different types of security in order to ensure that the individual or process seeking access to the target system is authorized and allowed to access it in that manner. So this is using a combination of physical access, logical access. It's using a combination of different technologies, be that firewall, be that monitoring, access control. Active Directory is a good example, LDAP, another good example of user authentication. You can do device level authentication, you can do certificates. So all of these come together, and that whole toolkit is what is used to protect your systems. And then in order to get past all of that, whether intentionally or unintentionally, it's much more complex to surpass. So this kind of brings up one of the key aspects, going back to NotPetya, that I found very interesting is NotPetya was very quickly able to traverse, once it was brought into the system, it was into a plan. It was very easy to traverse that network. And the reason being is specifically how it understood limited defense in depth approaches and was able to circumnavigate those. So I'll have a little bit more on that in a minute. The other aspect that should be a big part of any defense in depth approach is ensuring that you have a patching and lifecycle management plan. So in automation and controls and critical industry, there is a plethora of out of support operating systems. Windows XP was one of the first ones that really got a big news coverage because of these type of exploits. Windows Server 2003 is right in there. So April 2014 and July 2015, these systems were no longer supported by Microsoft with security patches at all, and that's years after they were supposed to have been retired. So looking at this timeline, we are looking January of 2020 for Windows 7 and Windows Server 2008 R2. So that means that systems that are, on 2003 and XP, you saw the last couple of years have cost companies tremendous amounts of money in outages and rebuild times. So coming up in a little over a year, we're going to have the next round of retiring of operating systems. So these systems need to be budgeted for now to be replaced. The vendors that are providing the software packages that maybe have prevented you from upgrading in the past need to be contacted now. And a lifecycle management plan needs to be put in place so that we're not looking at January 2020 thinking, okay, I'll install the new version of Windows and being told by the software vendor that it's not supported. One of the big reasons this is, this all gets tied back to finances as does everything, but a press release in 2017, Lloyd's of London, said that a well-executed cyber attack could cause damages around the world ranging from $53.1 billion to $121.4 billion. So to put that in perspective for the people in the U.S., Superstorm Sandy is considered the second costliest tropical cyclone, and the economic loss from that was around 50 to 70 billion. So a well-executed cyber attack would cause more damage than Superstorm Sandy. A newer statistic, this is from the 2018 DBIR, which is a report that Verizon compiles and puts out every year, the Data Breach Investigations Report. What they said is that it takes, of all the attacks that they analyzed, 87% of these systems were compromised in minutes or less. And in comparison, 2/3 went undiscovered for months or more. So the amount of time that nefarious actors had access to the system, or the systems were compromised, or the systems were in a state was minutes to attack and months to resolve. So that begs the question: what do we do? And for that, we have another body that provides a kind of a critical infrastructure for cybersecurity. So NIST, the National Institute of Standards and Technology, has the Cybersecurity Framework. And they just recently released a small update to that. They call it version 1.1. But the core of that framework is identify, protect, detect, respond, and recover. So everything we're talking about today, all of these different avenues and unknowns primarily, because I would think that a lot of the areas we're talking about, some of you may be thinking, yeah, okay, I kind of have a handle for how my network would respond to this, but maybe not that, but definitely not this. Oh, I've seen that happen. You're making some connections probably with what you've seen in the news, I would hope. And the question we should be asking is, what do we do next? So the first step is to identify. And the way that Grantek does that is through assessments, and most companies would do a very similar approach. So what we do is we would come out and do an assessment in the target area, and then that helps you know what you don't know. So that is the first step in admitting to not be an ostrich, pull your head out of the ground, and look around. And then you create a plan, with your partners, with internally, however it makes sense with your organization, you create a plan to assess and remediate that risk. Sometimes that remediation might simply be accepting that risk and saying, now that we understand it, we don't think it's a big problem, we accept it. Sometimes the remediation might be a very quick change to a policy. Okay, we're not going to allow thumb drives on in this area of the plant anymore. We're not going to use thumb drives to transfer these types of reports from this area to that area. We're going to put in a different system to do that. Sometimes the mitigation might be a multi-year process, or it might be a lifecycle management plan. So we know that our network is very out of date, and we have the funds to do this year and the next year, and then we're going to put in a 5-year plan so that we're actually life cycling the devices at the appropriate speed to which they become obsolete, and we're budgeting for that and being able to replace it with the appropriate amount of time. Sometimes these may be capital budgets every year, and if that does not work for the organization, increasingly there are partner companies, Dell and Cisco and others, that are offering leasing options for hardware. So if the procurement of new systems every 5 years doesn't work, then splitting that cost as a lease over one every year is another option to address the same thing. But the idea being is, step one is to assess and then implement ways to protect, detect, respond, and recover. So this is kind of an example here of what a selected assessment might look like. So if the engineers were to come to site, do a logical, physical, and compute assessment, they would look at those areas of the plant. They additionally would be able to look at controls and SCADA, vendor remote access, PI connectivity, various other aspects, and make recommendations based off of what they saw. All of this is just a report to give you the knowledge, and in a lot of cases give you the business justifications to go acquire funding in order to implement the changes that you need. So with that, I don't think I have seen any other questions come in, but the first one, we will be distributing the PowerPoint via PDF, so certainly you will have that. And then I have another question in here saying, I run a small manufacturing facility, and where do I start to address these issues? So that the answer to that would be to start working with your partners, with a company like Grantek or Panduit or whoever you have that is able to provide these types of assessments to determine the specific areas that you're interested in and determine where you are. Provide a risk scoring system so that you can then do that evaluation and over time work to reduce that risk. We take the same approach with our machine safety and other industries, other areas where that we can do a baseline and then over time work to create projects to improve the scoring of that, whether it's a machine or a plant or an enterprise. You should be able to show that the investments made are improving the areas desired. And was that it?
Yeah, this is Jason again. I did want to mention, if anybody wants a small sample of those lock-ins or blockouts, please email Chris at chris.hamilton@grantech.com. Send your name and shipping address, and I'd be happy to send you a sample bag to try those out.
Free stuff is always appreciated.
Absolutely.
Awesome. Well, thank you guys very much for listening, and I hope we gave you some valuable information. Again, comments, questions, very much appreciated. Shoot us a note or give us a call, and take care. Thank you very much.
Thank you.